Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from negative infinity to 6 r e to the r divided by 3 dr. This is an improper integral, so we can't use the fundamental theorem of calculus directly. We know that we can't because we've got an infinite limit of integration there. So we have to use the definition. This becomes the limit as a approaches negative infinity. The integral from a to 6 r e to the r over 3 dr. Then we treat the resulting integral as one that the fundamental theorem does apply to. And in order to do that, we're going to have to find an antiderivative. So let's take over here and try to find an antiderivative of r e to the r over 3. I bet we can. We could do an integration by parts. So let u be r, dv be e to the r over 3 dr, du, of course if u is r, du is just dr, dv is e to the r over 3 dr, so v is equal to an antiderivative, or you could think of it as the indefinite integral there. And when you integrate that, you're going to end up with 3e to the r over 3. So then we're ready to apply the integration by parts form. Integration by parts says that you get u times v, so 3re to the r over 3, minus the integral of v, 3e to the r over 3, du, which is dr. 3re to the r over 3 minus, when we integrate 3e to the r over 3, we get another factor of 3, so this actually becomes 9e to the r over 3. If you're not sure, you could go off and do a little substitution to get that done, and plus c. So there is an antiderivative. Coming back over to our limit, we get the limit as a goes to negative infinity of our antiderivative evaluated from a to 6. Notice that now we're doing a definite integral here, so the plus c is not needed. So to evaluate this, we substitute in the 6, so 3 times 6, e to the 6 divided by 3, minus 9 times e to the 6 divided by 3, minus, then we put the lower limit of integration in, which in this case is the a, so 3a, e to the a over 3, minus 9e to the a over 3. And we start to evaluate this out. Notice that everything in this term is a constant. So when you take the limit, nothing's going to happen. We could just simplify that sum. We get that constant. 3 times 6 is 18. 6 divided by 3 is 2. So we get 18e squared minus 9e squared, or 9e squared is what we have. On the second term, however, we really have to do some work here to evaluate that limit. A is getting closer to negative infinity. Here's what we can do. Sometimes it's a little difficult to imagine those limits as a goes to negative infinity. So what you can do is you can change it up. So here's the question for the moment. What we can do is we can let a be equal to negative b. So what does that mean? That means that now we're talking about the limit as b goes to positive infinity. Negative b would be going to negative infinity, so positive b would be going to positive infinity, so we can write it that way. 3 times negative b. Now, a is equal to negative b, so that negative exponent is going to drop that factor into the denominator. So this becomes e to the b over 3 minus 9. Again, a is equal to negative b, so this is e to the b over 3. In this way, we're now able to take the limit as the variable is approaching positive infinity, which sometimes is a little more clear what's happening. If b gets closer to positive infinity, then 3 times negative b gets closer to negative infinity. E to the b over 3 is going to get closer to positive infinity, so this first term becomes an indeterminate form. Well, let's deal with that in a moment. Notice for the second term, e to the b over 3, b is getting closer to infinity. When you divide it by 3, nothing much happens. You're still getting closer to infinity. E to that gets closer to infinity. So the denominator is getting bigger and bigger and bigger. 9 divided by that gets smaller and smaller and smaller. So this whole thing gets closer to 0. So really the only thing that we have left is the limit of this indeterminate form. And so we can use L'Hopital's rule to evaluate that. So by L'Hopital's rule says that you should take the limit now of the derivative of the numerator. 3 times negative b, its derivative would just be negative 3, divided by the derivative of the denominator. Well, the derivative of e to the b over 3 would be e to the b over 3 times the derivative of the inside. The inside is the exponent. The derivative of b over 3 would be 1 over 3. Now, as we see, the numerator here is negative 3. That's a constant. The denominator, just as we talked about previously, the denominator is getting closer to infinity. So the denominator is getting larger and larger and larger. This makes the whole fraction get smaller and smaller. So its limit is 0. Well, that took us a long ways, but we ended up with that second term being equal to 0. So in the end, our limit is equal to 9e squared, which is a perfectly fine number. This tells us that our integral that we started with, from negative infinity to 6, r e to the r over 3 dr, converges. It converges and is equal to 9e squared.